A 1 kilogram ball is dropped from the roof of a building 40 meters tall. What is the approximate time of the fall? Neglect air resistance. Okay, so if we're assuming that the ball is dropped from rest, we can say that the initial velocity is 0 meters per second. We know the displacement that the ball travels is negative 40 meters. Since it's downwards, we're dropping it from the top and it's going to hit the ground below. We also know that the acceleration due to gravity on Earth is also downwards at 9.8 meters per second squared. And we want to know the time of the fall. Note that the mass of the ball is irrelevant for this problem. Okay, so we can use this equation. Displacement is equal to initial velocity times time plus 1/2 acceleration times time squared. Our initial velocity is 0, so this whole term will go to 0. We'll have displacement equals 1/2 acceleration times time squared. Now to get time on its own, we're going to multiply both sides by 2 over acceleration. So on the left we'll have 2 times displacement over acceleration, and that'll be equal to time squared. So now let's plug in some values. We know displacement is negative 40 with a decimal point meters, and acceleration is negative 9.8 meters per second squared. Now if you evaluate this using your calculator, 2 times negative 40 divided by negative 9.8, you should get an answer of 8.1633, and that's rounded. Note that I'm keeping a lot of significant figures for now so that we can get a more exact answer when we take the square root, but in the end we're only going to want to have 2 significant figures since we only have 2 significant figures in our displacement and acceleration values. So we'll take the square root of this number. We should find that it's equal to 2.9, this was in seconds squared, 2.9 seconds, rounded to 2 significant figures. So this is the final answer for this problem. This is approximately how long it will take for the ball to hit the ground after being dropped from a 40-meter tall building.